All right, so linear. Fancy word for line, right? Okay. So linear function. A function is another word for an equation. Okay. So a linear function would be an equation for a line. Variable. Maylena, what's a variable? There's no right or wrong answer. Just tell me what you think it is. A number that you don't know yet. What else? Yeah, it is. It's something that you're trying to find a lot of times. Dan?
It's a symbol
A letter that takes the place of a number? Can we call it a value you're trying to find? A value you are trying to find or determine? You need to write, when you're taking notes, you need to write whatever makes sense to you. Okay? Someone told me once, they said, you can take notes the way you would text something. Okay? They're your notes. You don't have to copy down word for word what I put up there. What I put up there is what I think it is. All right? If that triggers something else in your head, then write that down. All right, you got a dependent variable. And I spelled it wrong again, didn't I? All right, the dependent variable. Which one was that? Yes. The dependent changes depending on the independent. But which one's the dependent? Is it the x, the y? Is it the vertical, the horizontal? Taylor. Okay, that's vertical, and that's horizontal. The up and down one? You don't sound real confident. The dependent changes in response to another variable, the independent. Values of the independent are inputs. Values of the dependent are called outputs. So the dependent variable, very good. The y value. All right? AKA f of x. Output. Range. Those are all the different names for the dependent variable. But they all mean the same thing. Okay? And let's say that it's on the vertical axis. All right, so then you got the independent variable. That's the x value, isn't it? It's this. It's the input. It's the domain. It's on the horizon axis. All right, turn the page in your book. Let's look at example 1. Page 256. In the diagram below, what is the relationship between the number of rectangles and the perimeter of the rectangle they form? Represent this relationship using a table, words, an equation, and a graph. So when there's one rectangle there, this is problem 1. Page 256. All right, so one rectangle. Perimeter was what? 14. So an ordered pair would be input 1, output 14. Two rectangles. What's the perimeter? You got the two rectangles sitting next to each other like this now. And that's 6, and that's 6, and 1, 1, 1, 1. So 6 and 6 is 12, 2, 2, 16, right? So what's your ordered pair? 2, 16. Three rectangles. What's going to be on the ends again? The 6s, aren't they? What's going to be on the ends every time? 6s. Are you starting? Is anybody seeing a pattern yet? What's the pattern? You got 3 rectangles. So we got 12 and 6. What's this going to be? 18. So our ordered pair. 3, 18. What's the pattern? Somebody give me the pattern. You're adding 2 every time here. But what if I told you there was 42 rectangles? What's the perimeter? That's what you're trying to do now. Okay? We're seeing this pattern. When there's 1, there's 14. When there's 2, there's 16. When there's 3, there's 18. These are going up by 1. These are going up by 2. Yes? By what? What we want to do now is we want to write a function, okay, that represents this information, because that's what we're working towards in this section. Being able to write a function that represents the data, okay? So our function that represents the data is our function of x is equal to, what do we have to do to x, which is our rectangle, to get y, which is our perimeter? What do you do to a 1, all right, to get a 14? Multiply it by what? Okay. But we had one rectangle. But what are you going to do to a 2 to get a 16? Right? But our formula or our function has to be the same every time to get this, to get your ordered pair. Look at it in terms of how many rectangles there are. One rectangle, okay, perimeter is 14. What was common every time? Weren't those 2 6s common every time? So if there was 40 of those rectangles, don't you got a 6 at the beginning and a 6 at the end? And what's a 6 at the beginning and a 6 at the end? 12, isn't it? So don't you got to add 12 to something every time? Okay. Times 2 plus 12. You need to say that louder. So 2x plus 12 is your function, with x being the number of rectangles and your y, or your function of x, being the perimeter. Okay? Your ordered pair, this is x and function of x, also known as y. Okay? So 2 times the number of rectangles plus 12 will give you the perimeter. Let's look at the bottom of that page. Now you've got triangles, right? And they look kind of like here, here, here. What's this? 3, 3, and a 4. And then when you go to 2 of them, and what's on the ends again? And then when you go to 3 of them, you go here, here, here. And again, the ends. So based on what we just did, can you think of a function rule? What are you going to add every time? Aren't you adding 6 every time? Okay, so we got a plus 6 that's going on. How many triangles here? And how many 4s? How many triangles here? How many 4s? So isn't it 4 times the number of triangles plus 6 would give you the perimeter, wouldn't it? Okay. A function. Relationship that pairs each input value What's another name for input? X. What's another name for input? Domain. What's another name for input? So a function is a relation that pairs each input value, each x value, each domain, each value on the horizontal axis. Alright, it pairs it with exactly one output value, y value. range value. Vertical axis. Okay? And here's some examples of a function. Here's what a function looks like. A function could look like this. Y equals 2x plus 5. Function notation is when you write that, you read this, f of x. F of x is short for function of x equals 2x minus 4. The function of x equals 1/2 x. The function of x equals -5x. Those are all functions. That's function notation. These are all functions. You can change up the letters. You can have the function of a, 3a plus 12. Now your a is your input value. Okay? It's on your horizontal axis. It's your domain. But instead of using the letter x, you can use the letter a. What other letter can you use? You can use any letter you want, can't you? Okay? You can have the function of m is equal to 3m minus 15. These are all functions. It doesn't have to have an x in there to be a function. Okay? Alright, tomorrow we're going to work on the lesson check in class. And then you're going to have a quiz on Friday. Okay?